Now we got to do kinetic friction. All right, let's do it over here. So all that was about things not moving. All we did in terms of motion is we calculated the limit where something starts moving. We didn't actually calculate any values for something actually moving. Did we? No, we did not. When does static friction turn into kinetic friction? Right now in the lecture. At the 21st minute. 26th minute. Kinetic friction. It turns into kinetic friction when it starts moving. Right? Is Fk, we use a little subscript k to mean kinetic, between two surfaces right? It's not the friction force of something moving. Something can move and not be feeling kinetic friction, like I showed you with the two blocks, right? It has to do with the sliding of an interface. The Fk is between two surfaces sliding against each other. Sliding against each other. I'm a few letters away from trouble here, okay. Okay, so now let's draw it first. And say here's a surface, right? And here is a block. And we're going to give the block an initial velocity like that, right? So now two surfaces are sliding against each other. The block is sliding against the table. So you know what's going to happen, right? Initial velocity, and it stops. I gave it a velocity. The velocity slowed down. The velocity changed. There must have been acceleration. What caused acceleration? A force, right? So there was a kinetic friction force back here. Do these cancel? No. This is a cartoon. I drew velocity here just to give you the feeling of a velocity. I drew a force this way. When you're doing the cartoon, you have all kinds of different vectors. Don't get too intuitive about them canceling. These aren't going to cancel. This implies this one will get smaller, but don't get drawn into a drawing. I don't know. So a wheel experiences no friction rolling. Oh, it does. A wheel is a device that lowers the friction a lot. Okay, that's what a wheel does. I don't think we're going to do wheels too much. It's very confusing. What happens when the friction force equal to the coefficient of static friction, x, the normal, is it motionless at the exact moment? We'll talk about that in a minute. Okay, so here it is. Let's do the free body diagram of this thing just for fun. mg down, normal force up, and Fk to the left. The velocity is not a force, right? When you do a free body diagram, that's only for forces. You don't go drawing velocities and positions on it, right? So there's your FBD. And the magnitude of the kinetic friction, this is actually a lot easier because the magnitude, I'll put the bars to really stress, this is the magnitude, is simply equal to mu k times the magnitude of the normal force. Not less than or equal to, it's just equal to. So it's just a constant. You don't have to worry about, well, how fast is it going or whatever. No, it's just a constant. Now, it only is there if the thing is sliding. But as long as it's sliding, constant force. Okay, and then mu k, as you can tell, if you're into symmetry, is the coefficient of kinetic friction. Right, and it's also usually about 0.5 plus or minus 0.45. Right? So it's between 0 and 1 usually. Right? 0 would be a frictionless surface. It can be as high, it can be above 1 in principle, but it's usually below 1. Okay?